We introduced geometry with three undefined terms, and those three things are a point, a line, and a plane. So a point is basically a tiny dot, but it can be where two things come together. So like the corner of a box, so of a Kleenex box, you could have a point right there. But it also can exist in other spots. Points can exist on lines. So a line is straight and goes forever. That's why you put arrows on each end. And there can be points on that line, and there are points on the line. And then this is a plane. Everything lies in a plane. So when you name these things, and the plane goes forever, by the way. It's not just a rectangular shape, but it's flat and it goes forever. Naming things, you need to be real careful and do it properly. Points always have a capital letter next to it, so I would call that point A. Lines, this line has to have at least 2 points on it to make the line. So this could be line BC, but it could have many other points on it. The plane could be named by a capital cursive letter in the corner or by any 3 points that are not in the same line. So that brings up another term. There are non-collinear points. So the word non, that would mean they are not in the same line. And then there are collinear points. Collinear points are points that are in the same line. So I could add another point here, and I could say B, D, and C are all collinear points. If I had to name non-collinear, I could say B, D, C, A. Usually you want to name at least 4, but it just depends on what they're asking for. This would be called plane K, but I can also call it plane BAC. So any 3 non-collinear points will name a plane. It's kind of confusing, but you'll get the hang of it. Let's talk about this situation now. There's lots of things going on in this picture. This is 2 planes that are intersecting. They're intersecting right here at this line. Anything you see that's dotted means that it's there, but it's behind and you can't see it. There's a line here. It's going through this plane, and I know it's going through it instead of just lying on it like EF because I see the dotted line. So anytime you see dotted lines, you know something's there, but it's behind and you can't technically see it. So I've got some questions. Name 2 points. So when I name points, I can find any points here, but I want to use capital letters when I name them, and I want to write it with a comma between. So P, I could say point P and R. That would work. So here's point P, here's point R. Name a line. The way I would name a line is I would find one. So this one's the best one because I can see 2 points on it. I am going to put that symbol above EF. Now, I could have said FE, so either way. And then name a plane. I see 2 planes. So I can either name this one's plane K, or I could name that one plane M. But I could also take any 3 points in plane K and name it that way. So I could say plane EFR. Now I'm looking at 2 things that are pieces of a line. So that's why we introduced point, line, and plane. Everything comes from those 3 things. So if we didn't have a line, then we couldn't have a segment or array. And that's what these are. So this is a segment. And this is array. So I can name this segment CD or DC. A segment has 2 endpoints. Array has 1 endpoint. You have to be careful how you name array. whatever the endpoint is has to come first. If my ray is drawn this way, RS, I still have to say RS when I write it using symbols. I want to talk about what happens when you have two rays. So if I have two rays that meet at the same endpoint, then now I have an angle. So that's the definition of an angle, when two rays meet at a common point. This would be an angle. The way you name angles is with the angle symbol. There are several ways to do it though. We can say CAB, BAC, angle A, and then sometimes there's a number inside it. So like if there's a 2, we could say angle 2. Notice how the point that they share is the one that's in the middle. It's the corner. It's also called the vertex. You want the vertex, if you're going to name it using 3 letters, you want the vertex in the middle. Sometimes you have to name it using 3 letters because it would get confused with another angle. So be sure you recognize, I better use 3 letters on this one because then they're not going to know which one I'm talking about. But here I could use just 1 letter and you knew exactly the angle I'm talking about. So if I wanted to name a circle, I look at the center point, and that's how I name the circle. So this would be called circle C. Just like there's collinear and non-collinear points, there are coplanar and non-coplanar points. So coplanar would mean they are in the same plane. All the points that I might name have to be in the same plane to call them coplanar. And non-coplanar would be points that are not all in the same plane. One of the easiest ways to make sure that you name non-coplanar points is choose all your points except for one that are in the same plane and then choose one that's not. You don't have to do it that way, but that's just, that is one way of doing it. So I have a picture of my Kleenex box that I was holding up earlier. So I've got 6 planes here. This has 6 planes. The lines could be edges, but they could also be lines, like on this design here. I see some lines. I see a line there. And like I said, there could be points in the corners or in other places. So I have my Kleenex box. If you see dotted lines, you know they are there. You just cannot actually see them like if it was an actual object. You would not be able to see it. But since we can draw it, we can say this is a 3-dimensional figure, and you know that by my dotted lines. So if I were to put points here, I wouldn't be putting any points where you couldn't see them. Everything that I have here are things that you can see. So for instance, C is lying in this front plane. It's not back here on this plane that you cannot see. I did not name my planes, but I could have named them by putting a small cursive letter in the corner. But you can also name planes using 3 non-collinear points. But what if somebody said, what are 4 coplanar points that you see? Well, I only see this one that has 4 points in it, so I would naturally go and name that one, but I could have done it in any of them where I see 4 points that are in the same plane. So G, D, H, and E are all in this plane. Also, when you name coplanar points, do not name everything in the same line. If you do that, technically another plane could go through that line and those points could be contained in another plane. Non-coplanar points, I just chose any 4 that were not in the same plane together. Even though G and D are, F is not and C is not. So that would be non-coplanar. coplanar. Another term that you're going to see or hear a lot is adjacent. Adjacent angles are two angles that are side by side and they share this side. So they will share a ray. They do not overlap though. And you'll see that situation arise where they'll ask you, name two adjacent angles. Just make sure that you're not naming things that overlap, or they may ask you, are these adjacent? And you've got to check to see if they overlap. It would be more of a complicated picture. They may say, our angles BAD and angle BAE adjacent. And they're not, because one angle is inside the other. BAE is this whole angle. So when you see an angle named, follow it. BAD. So we're talking about this whole angle. BAD was BAD here, and then BAE was the whole angle. But BAD is inside of BAE, which means they overlap. These would not be adjacent. They, to be adjacent, have to share a side, okay? Technically, I guess they do share BA here. Both of them have BA. They share that side, but they cannot overlap, so that's the key. All right, so those are adjacent angles that do not overlap. So if they said name two adjacent angles here, I could either say angle 1 and angle 2. So that would be the quick, simple way to do it. I cannot say angle B this time, because if I just say angle B and name it using one letter, you're not going to know which angle I'm talking about. So if I wanted to name it using 3 letters, I would need to go A, B, D, but it would be perfectly okay to go DBA. And notice how I'm splitting things up with the words and I'm also, if I'm naming points, I'm using commas between them. Keep everything organized. CBD, or I could have said DBC. So let's get specific on some angle type things. There are 4 types of angles. You can have right angles where it's equal to 90 degrees. You see the little marking for 90. If I open that up wider than 90, then it's called obtuse. So that's greater than 90. If I close it smaller than 90, then it's acute. And if I lay it out flat, it's called a straight angle. So this is 180 degrees. Any line is 180 degrees. But this would have to be less than 90, and that would be more than 90. So when you talk about different pairs of angles, I can have a supplementary pair or a complementary pair. That means 2 angles that are either 180 or 90. So I've given you 2 situations here. This one is an adjacent example. I've got a 120 and a 60 degree that add up to 180. So these 2 angles would be supplementary. They may say, what is the supplement of a 120 degree angle? You would say a 60 degree. So when you see the word supplementary or supplement, you know they're wanting things that add up to 180. Here's an example where the 2 angles are not adjacent, but still they're a pair of supplementary because 130 plus 50 is 180. A trick to remember supplementary is I can change this S to an 8 and put a 1 and a 0. So there's 180. For complementary, we want 2 pairs or a pair that adds up to 90. So a 30 degree and a 60 degree angle would work. This is a non-adjacent pair. Here is an adjacent example. So they share this common side, but we've got a 50 and a 40 that add up to 90.